Hello class, our next chapter is rapid variable flow. And what is rapid variable flow? Suppose there is short lane and in this short lane the depth of the flow suddenly change. Depth of the flow suddenly change. So in this section there is a rapid variable flow. So there is suppose not suppose there is even when depth of flow is too much low, so here is supercritical flow, and when the depth is suddenly abrupt, so it will be a subcritical flow. So when the flow is changes from supercritical to subcritical, there is a jump. So this jump is called as hydraulic jump. And in this hydraulic jump, there is in this hydraulic jump there is energy. Suppose there is a flow and this is the jump. So there is a turbulence between the jump. Turbulence. This is the turbulent rollers. It will form in the jump. So some examples where the jump is formed. So here is the at the bottom of a spillway, a downstream of sluice gate, an irrigation channel falls, and much more examples of hydraulic jump where flow is changes from supercritical to subcritical. This is the application of hydraulic jump. So where it is used as it is used as a energy dissipator at the bottom at the downstream side of the dam or spillway, and at the bottom of spillway, and to mix chemical used for water purification or wastewater treatment plant, and to aerate polluted stream. So here we see the hydraulic jump. Here it is a toe of jump. This is known as toe of jump, where the hydraulic jump is initiated or generated or produces, and this is the end of jump where is flow is converted to subcritical flow, and this is the length of jump. So here is a change in depth. Suppose this is y1 and this is y2. So it will called a secant or conjugate depth. So here secant or conjugate depth where the discharge is constant, and we draw a graph of depth to specific energy. So it will give uh, at a specific energy it will give uh, two depths at a point. So it will say conjugate depth. We can say that conjugate depth, and at the critical point the specific energy will be minimum. At the critical depth specific energy will be minimum. So here why it, and above the critical depth the flow is subcritical, and below the critical depth it will supercritical. Now the second depth ratio, that means y2 by y1 or y1 by y2. So here we use a specific force second, because second depth in hydraulic jump are depths with same specific force, because the same force is same. So specific forces we will see in OCF first chapter. So it will P plus m by gamma, that means pressure plus moment divided by unit density is the constant values. This is constant. So P is gamma a y bar plus rho qb by gamma. This is momentum. So cut the gamma value and it will give a y bar plus qv by g. So here v is the velocity, so v is discharge upon area, so it will be q square by ag. Now suppose we have a rectangular channel of width d and the depth of the flow y. So here is the area dy and y bar is y by 2 plus discharge q is q square divided by v by g equals to k, that means constant. So here v is constant, v is, we remove the v from here, that will give y square by 2 q square by v square by v square dot by g. So discharge by v, it termed as small q, which is equals to discharge per unit width. So y square by 2 plus q square by yg equals to constant. So for the two sections at y1 and y2, here is y1 square by 2 plus q square by y1g, because discharge per unit width is same, so y2 square by 2 plus q square by y2g. So हम अलग करते हैं इसको, क्यू स्क्वायर एक साइड आ जाएंगे क्यू स्क्वायर वाले टर्म्स, और जो y1 और y2 है वो वन साइड आ जाएगा, ठीक है. सो इट विल गिव क्यू स्क्वायर बाय g इक्वल्स टू y1 y2, 2 q square by g equals to y1 y2 y1 plus y2. This is one equation for the adult depth. Okay, so we know the Prandtl number. Prandtl number is f equals to velocity. Okay, now the expression will be continued in next lecture.